this, and I'm going to try while I'm here on campus, and the internet is somewhat more reliable apparently than it was at my house over the weekend. I think my internet knows when I'm stressed out and trying to get a bunch of stuff done, because it just says, no, we're just going to mess with you. We're not going to work. So,
Stay up there.
yeah. So I did get the video loaded for section 10.2 and 10.3, and it is in Shobi, and before we leave today, I'll show you where the link is. The notes that you have, whether you're doing them on your tablet or you're doing them on pencil and paper, the notes you have are good for all of chapter 1. So my notes packets are one whole chapter at a time. It's just you'll have shorter videos because theoretically at least, shorter videos load up better, but it just wouldn't load chapter 1, section 1. So we're going to do that this morning, and I am recording it, and I will post it in here if you need to go back and review your notes. So if you can't keep up with the lecture, don't worry about it. Worry more about listening than you do about writing. Write down what you really need to, especially, maybe if there's a place where I'm talking and you didn't get something, mark your notes that you need to go back and listen to the video again and fill in those notes. And then if you still have a question about it, then you can ask me right there in your Shobi folder. I didn't understand this on page whatever. Can you help me? And I'll be glad to do that. So getting started here, we're going to work on chapter 1. Now everybody should be, maybe not totally a master of drawing graphs of lines and plotting points and that kind of thing, but it shouldn't be like, I've never seen this before in my whole life. Because if you had high school algebra 1, at any point in your life, you've done this. If you completed Math 1100 as the prerequisite to this class, you've done this. So you've seen this before somewhere, okay? I'm not going to go slow except over places that I think you really, really, really are not going to be familiar with it. So I'm going to try to take my time on the parts that I know is new, and I may go a little quicker over the parts that I think you've already kind of mastered. But if that's not the case, do not hesitate, ever, to raise your hand and say, Ms. Flint, I didn't get that, I don't understand. Would you stop and maybe explain that a different way? Don't be hesitant at all to do that. Knowing that people are sometimes uncomfortable to raise their hand and ask in class. That's why I record, because then you can go back and you can hit that place where you were stuck. Maybe listening to it again will help. If it doesn't, then you ask me the question either there or in Remind. You can send me a question in Remind. It'll come to my phone and I'll answer it usually pretty quickly. I got behind last week because everybody was trying to talk at once. But I do get a notification when you ask me a question in Remind. I also get a notification if you're right there in your Shobi folder and you're working. You just go up there and make a comment in that folder. It sends me an email and tells me that you've asked a question in Shobi, and I can click the link and go right to where your question is. So what are we going to talk about in chapter 1? Well, we're going to talk about linear functions. The linear part, like I said, you graphed lines, but maybe functions you don't understand really well. One of the things I want you to pay attention to the most is not necessarily these definitions and theorems and properties, because I'm not going to ask you all that stuff on a test. We're going to do mostly some examples and look at some pictures and learn how to build tables. And I'm actually almost glad I couldn't get the video to upload for 1.1, because when I do things and explain everything, I can't show you the calculator steps. But while I'm doing this, I can actually walk you through the calculator steps to do some of the things we'll do. So the first thing we're going to talk about in section 1.1 is slopes and equations of lines. I expect those two words to be familiar to everybody in here. This shouldn't be totally foreign, although you may not feel like you really are a master at this. That's okay, as long as you've seen it before, so I'm not starting you from scratch. And this is the usual question that I get asked. Every math teacher faces this in every course that we ever teach. And You know, y'all know that this is, you know, why do I have to do this? Why is this necessary? Why are you making me learn this? What am I going to do with it? What's it good for? Well, the reason that we need to study linear functions is because there's a lot of everyday situations, especially since I'm assuming all of y'all are business majors, or maybe for some reason you're going to be doing applications, even if not business applications. There's a lot of situations where two quantities are related to each other. For example, if you have a bank account and it pays 6% simple interest, and it pays that on a yearly basis, then the deposit of P dollars will get you I, the amount of interest per year, by using the formula interest, or I, is equal to 0.006 times the amount of money that you put in the bank to begin with. So if we use that formula, we can see, for example, that if you let P be 100, then the interest is going to be $6, and that's going to be because if you multiply 0.06 times 100, then you get $6. You use a calculator. And if the amount you deposit to start with is $200, then the amount of interest that you'll get for 1 year at the end of that first year is going to be $12, because 0.06 times 200 is 12. Well, as it turns out, those are ordered pairs. The first part of that ordered pair is going to be the amount of money that you put in the bank. That's going to determine the amount of interest you get at the end of the year. So the variables are the principal and the interest, and the principal is going to determine how much the interest is. So when we write ordered pairs, we're going to put the principal first because it's the boss. It gets to say what happens to the interest. And then we're going to put a comma and then put the interest amount. And those two ordered pairs give us some information that will help us come up with equations or slopes of a line. Just keep in mind that these are ordered pairs. The order is important. One of the things that we do with ordered pairs, and I know this really isn't, you know, in application, but this is a little abstract. Ordered pairs are graphed with the perpendicular number lines of what we call a Cartesian coordinate system. The x-axis and the y-axis are both number lines. And they're numbered going from 0 to the right are positive numbers, 0 to the left are negative numbers, or if you're talking about the y-axis, from the 0 up is the positive numbers and the 0 down is the negative numbers.
What do you call that?
The Cartesian coordinate system. Okay? And if you're wondering where they came up with Cartesian, René Descartes was a French mathematician a few hundred years ago. He was also a gambler. He was a lot more famously known in his time for being a gambler. He did a lot of work with probability because he was a gambler and that was of an interest to him, but he was the actual inventor of the Cartesian coordinate system, which we call a graph grid, a two-dimensional graph grid. So if you want to hate somebody for having a graph, I guess you might have to blame René Descartes. So as I said, the horizontal number line, which is called the x-axis, represents the first components of the ordered pairs. When we were talking about the principal and the interest, the x-axis would represent the principal. Okay? And the vertical or y-axis represents the second components. So that means that the y-axis represents interest in this case, if we're talking about that first problem. The point where those two number lines cross is at the 0 on both lines. That's a number that they both have in common. That's called the origin. So that origin is the point 0, 0. And every point in that plane, that flat surface, represents an ordered pair, an input and an output, because the x-axis, you'll hear me refer to the x values, or the first value, as an independent variable or an input. And then the second part of the ordered pair is always the dependent variable or the output. If you put in a number for the x, you will get out of the formula a number for the y. So if I was going to try to locate the point 2, -4, I'm going to start at the origin, right here. And I'm going to count to the left 2. So there's 1, 2. And then I'm going to go 4 units up because the 4 is positive. So again, 1, 2 to the left, and then up 1, 2, 3, 4. And that gives me the point -2, 4. And you can do that for every single point that's on that graph. The -2 is called the x-coordinate, and the number 4 is called the y-coordinate. This may be a little new, and then again it may not. There's 4 parts on that graph. Those 4 parts are called quadrants, and the 4 quadrants are equal in size. Even though all of them go on forever, they still remain equal in size. Quadrant 1 is the one that we will use the most often in applications. And the reason for that is because in quadrant 1, that's going to be all the points that the x-coordinate and the y-coordinate are both positive. So think about our interest, our principal and interest. Are you going to be able to put in a negative amount of money into that bank account? No, so there's no need to go to negative x values. Are you going to get a negative amount of interest? Are they going to charge you for holding your money? No, so that means there's no need for negative y values. So most real application problems deal mostly with quadrant 1. And that's going to be where both of the coordinates, x and y, are positive. We number the quadrants counterclockwise, meaning the opposite of the way that a clock goes. So this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4, and then you go back to quadrant 1 if you circle around. Now notice, as I said, quadrant 1 you have points that are positive, positive. In quadrant 2, x is still positive, x is negative, but y becomes positive, so you're going to the left and up. So that means that your coordinates are negative, then positive. When you go to quadrant 3, and this is the quadrant that we almost never use in realistic applications, that's where both of the components are negative. Your ordered pairs will be negative number, negative number. And then in quadrant 4, x is again positive. We will sometimes have applications where it's possible that your x's would be positive, but your y's come out to be negative. That would happen maybe when you're graphing your profit equation and suddenly you're not making money anymore, you're losing money. So that makes your profit negative. So that might be a positive number of items that you manufacture. You might actually lose money making that many items because it costs you more to make them than you actually gain from revenue selling them. So that those 2 quadrants actually have some application for us, more so than quadrant 2 and 3. This is a graph of a linear equation. You know it's a graph of a linear equation because it's a straight line. It has an x-intercept and a y-intercept. The y-intercept is b, but b only tells you where it crosses the y-axis. And at this point, I'm actually going to stop using that, and I'm going to go so that I can explain some things to you a little bit better. The y-intercept is a point. Okay, it's a point. And because it's a point or an ordered pair, you always write the y-intercept as 0b. B is the second coordinate of that point. It's 0B because you start at the origin and you don't go right or left because you're on the y-axis. And then you simply go up B units. So this point is 0B. Please don't tell me a y-intercept is y equals some number. Y equals some number is a line, as we're going to see later on. An intercept is a point. Be sure to write that down somewhere if you're in the habit of not having to write it as points. Your book is really kind of bad to let you get by with calling a y-intercept y equals something. That's not really technically correct. It really is a point. That y-intercept is a point. Your x-intercept is also a point. Your x-intercept is where it crosses the x-axis. If it's going to cross the x-axis, it's going to go right or left, but it's not going to go up or down. So that means that your y-coordinate of your x-intercept is going to be 0. So this point is, while that x number is A, the correct point is A, 0. Okay? So remember that your x and y intercepts are always points. Give me now, this is an important thing that we're going to have to talk about, and it's not that you've never heard this before, I'm sure you have. An important characteristic of a straight line is its slope. You might think of slope as slantedness. How does the line slant? It's a number that represents the steepness of the graph, or the steepness of that line. On the one that we're looking at here, we see that this line passes through the points -3, 5,
And it also passes through a second point
to -4. Now when we're talking about slope, we're talking about how can I get from one point to the other point without walking on the line. That's probably the best way to explain it to you. How do you get from point A to point B without walking on the line? Not the straightest way to get there, but how, if you have to walk along streets, this is not maybe a street. These, the horizontal and vertical lines you can consider to be streets, and this is building A and building B. So if I have to walk along the streets, get from building A to building B, how do I do that? Try to think of it that way. Well, if I start at point A, and I'm trying to get to point B, point A, I'm at x-coordinate where it is 3, trying to get
to its to the other x-coordinate, the x-coordinate of B, which is 2. So what I'm actually going to do is I'm actually going to try to get from -3 to 2. That means I'm going to go 1, 2, 3, 4, 5. 5 units to the right. Okay? Then from there, I'm on a street corner, and I'm going to turn and I'm going to walk down from here to here, which means I'm going from 5 here to 5 axis. So I'm going to go down to -4,
which means I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9.
So I'm going to go down 9. That means that 9 is negative. So we're going to call that negative 9. And that's where this negative 9 comes from. So that means that line has a negative slope. The slope of that line, which we call M,
is down 9, right 5.
okay? Down 9 and right 5. Always let this top number tell the y value.
And the bottom number always tells us the change in the x value.
And it would have been just as correct, since I'm trying to get from here to here, it would have been just as correct. Well, I'm going to go down from 5 to negative 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then go right. 1, 2, 3, 4, 5. Right 5. So the slope tells you how far down, how far to the right. And you read it from top to bottom. Okay? These symbols, these triangles, means the change in. It's also referred to, change can be referred to as a difference because you subtract to get the differences. So it's also referred to as the difference in. So another way to think of slope then is the difference in the y values divided by the x values. Because we're going to be doing subtracting. Okay? Now what I'm trying to do here by phrasing things the way that I am is I'm trying to give you the idea that yes, I will give you the formula for slope, but I need you to understand the concept of slope. What is slope? And we're going to talk later on in this course about something called a difference quotient. Slope is a difference quotient. Okay, as we get into calculus, we talk a lot about difference quotients. It's the quotient of a pair of difference. Quotient means you're going to divide. Okay? I'm going to show you an easy way to make sure you always get the slope right and you never get it mixed up and wind up with the opposite of the slope that you're supposed to get. And you're not going to really want to use a formula as much as once you see the placement of things, you don't really need a formula. So, slope of a line. Let's continue and talk about that formula that I'm telling you you're probably not going to need. The slope of a line is defined to be the change in y divided by the change in x, or delta y over delta x. Now, I don't really like this idea of a formula except for the fact that it does help you see something that's important. It doesn't matter which point comes first. This seems to imply that it does. But it doesn't matter which point comes first. What matters is that the coordinates of the points stay together on either end of this slope formula. So if you have x1, y1, I want you to notice that x1, y1 have to stay together when you stack it up. And if you have x2, y2, they have to stay together when you stack it up. So what this tells me is that I could just as easily have found the slope by doing it this way.
The order of the individual points matters, but the order that you put them in the slope formula doesn't. I could just as easily have used x1 and y1 at the beginning, and x2 and y2 on the other side. Both of those will give me the same slope. The thing you're going to need to be careful of is that you don't want to cross those up. And I'll show you what happens when we do an example. If
You actually do that. Now, by definition then, the slope of the line that we just looked at, and we already know what it is because we counted it off on the graph,
the 2 points that we had were -3, 5. And 2, -4. So we could have found the slope really easily, knowing that the slope is a difference quotient, which means we have a difference on the top and a difference on the bottom.
Is this just something that we need to kind of just jot down because it's not in our, it's like not in our notes?
If you don't understand it, you want to go back and listen to it again and write down what
So
you
this
need
isn't
to.
like supposed to be in our notes?
It's not necessarily in your notes, no.
Okay,
Yeah. I go into more detail than what the notes do.
Okay.
And then I'll let you choose what you need to put down for it.
okay.
So in this case, as long as I keep the coordinates of that point together, and I put the x's on the bottom, that's the main thing, bottom. Y's go on the top. Got to remember that. So the x is -3, the y is 5. The x is -4. I'm sorry, the x is 2, not -4. And the y is -4. So you always go x, y, x, y. Okay? So then what we're actually doing to calculate this slope (5 minus -4) is the same as 5 plus 4, which gives us 9. 3 minus 2, since they're both negative, you add the numbers and keep the sign. 3 minus 2 is -5. So my slope is 9 over -5. And usually we'll pull that negative sign out front so we don't lose it, and call that -9/5. Now here's what, and I'm going to be repeating this later on in another example, so if you're not quite getting it right now, you're going to hear this again. It would have been equally correct for me if I had decided to write that slope this way. Remembering that it's a difference quotient, a difference on the top, a difference on the bottom. But I decided that I'm going to put the blue point first. 2, -4. Then I'm going to put the pink point. -3, 5. So what happens when I say -4 minus 5?
So -9.
That's -9. And what if I say 2 minus -3?
Positive 5.
That's +5 because it's 2 plus 3. Is -9 over 5 the same as 5 over, or 9 over -5? Is it still just -9/5? Yeah. Remember in this one, when I said that I could count right and then down? Or I could count down and then right, and I'm still going to wind up at the same place? That's telling you can reverse the position of those 2 points as long as you keep them with their partners. You cannot break up the partnership. Okay? So that works just fine.
But you always put your X's on the bottom.
X's are on-
Y's on the top, and subtract
and then subtract.
That's gonna be your number.
That's right. That's exactly right. Put your x's on the bottom, your y's on the top, and subtract. Just be careful that your x's and y's stay with their partners. They don't get crossed up. And what I'm trying to explain to you there is if they get crossed up, here's what you can't do. There's your difference quotient. I can't take this point and put it like that. Which means then my other point would have to be like that. I can't do that. Because what happens if I do that?
The numbers will get mixed up.
The numbers are mixed up. The points are mixed up now. These two are partners, but they can't reach each other. These two are partners, they can't reach each other. And what that does to the slope is it gives you a messed up answer. 5 minus -4 is 5 plus 4, which is 9. Okay, that's fine. I got 9 a little while ago. But then 2 minus -3 is 2 plus 3, which is positive 5. And 9/5 and -9/5 are not the same thing. So even though this and this were the same, that's fine. These two aren't the same. They have a different sign. That's what's going to happen if you mix up the partners. Something negative happens. You get the wrong sign. If you got two couples and they get mixed up on their partners, what happens?
Diseases.
Bloodshed. At some point, maybe bloodshed. They want to stay with their partners. So,
For that reason, just be sure that you remember the partners. You want to keep those together. Okay? That's the only thing you take away from this lesson. I'll be happy.
You're just saying keep your X's and Y's.
Keep them together. Keep them together like this. So here's another example. I want y'all to work through this one, then I'm going to ask you a question. I've got 2 points. When I have 2 points, I'm telling you something. This is the actual way that I did this to make myself learn not to mix slopes. I always have 3 colors of pens. The black one or the pencil I write with, then I have 2 colors of markers. I choose one of the points by searching one of the colors and the other with it. And I use those markers to actually do my work so that I know what order I'm doing. So I'm just remembering that my slope formula I always do. To me, that's the slope formula right there. I don't need that thing with all those numbers in it. That's I have to remember X on the bottom, Y's on the top. Now I'm going to work for you. I'm going to demonstrate to you again that if you partners, you're going to get the right answer, partners simply goes first. I'll do that on the next one. I'm going to make you do the next. So 7, 6. 7, 6. -4, 5. I do the math. 6 minus 5 is 1. 7 minus 4 is 11. And I get a slope of 11. Okay. My same slope formula. Keep your partners together. Together only either way. What's 5 minus? Okay. What's -4 minus 7? What happens if a negative over a negative? They cancel out. 1/11. Same slope as one partnership. Okay? Gotta keep the partners together. And I actually already did that on this sheet, on the PowerPoint. I reemphasized, the key is that the coordinates have to remain together. Okay? That's important. Keep your partners together. This one is for you. I want you to number off, starting over here. 1, 2. And then again, 1, 2. No, 1, 1, 2, 1, 2, 1, 2, 1, 2. We'll start back here. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Everybody that was a 1. Use that point. That point is your first point. Use that point as your second point. Everybody that was a 2, switch them around. This is your first point. That's your second point. So 1s, red comes first, blue comes second. 2s, blue comes first, red comes second. Calculate the slope for me. When you get yours calculated, turn to the person next to you and see if they got the same answer you did. Because the person next to you should be doing it the other way. But your answer should match. You mean both numbers now. Numerator and denominator.
How did you get, this should be 7, this should be 3, because -2 minus 5 is 7. Carry out this.
Here's some talking going on, that's good. Help each other out. If you didn't match, figure out why.
I'm switching my majors. And that's all.
Minus -3 over -2 minus 5.
Okay,
Yes.
volunteer, what did you get?
0.
Okay, 0 over what? Because there was a,
0 over 7, but if you divide out the number, it's still 0.
it comes out to be 0, that's fine. But I wanted to be sure that everybody realized what both of the numbers were. Let's see, you were a 2, you were
I was a 1.
You were a 1, okay. Somebody that's a 2, what'd you get? 0 over 7, same thing. Which actually comes out to be 0. Does anybody know or want to volunteer what does the slope of 0 mean?
It's a straight line.
Well, so was the other one, so how is it different from the other one?
-7.
You got 0 over -7?
Yeah.
Yeah, that's what I have.
And then you crossed up your points. Okay? If you got 0 over -7, this is what you did.
-2 minus 5 is -7. Yeah.
Okay, well, I'm going to not cross up my points, so let me try this again. 5, -3, -2, -3. I'm subtracting, negative, negative. Negative 3 minus negative 3 is in fact 0. 5 minus negative 2 is 5 plus 2, which is positive 7. If I do it the other way, three minus negative 3 is still 0. 2 minus 5 is, indeed, they're right, it could be negative 7. What would have happened if you did cross up your points? This is a good place to make sure that you're not crossing them up. What would have happened if I crossed up my points and I separated them from their partners? In this case, it would not have, because I'd still have negative 3 minus negative 3, which is still 0, and negative 2 minus 5, which is negative 7, so nothing bad would have happened this time. But did it matter on the other one? Yes, it mattered a lot. So even though this worked this time, this is something, I'm glad that actually came up here. Even though that worked, you still can't do that, because there's a lot of little tricks you learn in math that they work that time, but if you try to apply it every time, it doesn't work. Okay? So remember, just because there's something you remember in the back of your mind, if you're not sure if it always works, it's a shortcut you learn, but you're not sure that shortcut is always going to work, ask me, and I will tell you if it won't work. I won't show you a shortcut in this class unless I know that it always works. This is kind of like my shortcut, because it always works as long as you keep the partners together. What does it mean because the slope is 0?
It's the origin.
Okay, the origin is 0, comma 0. What does it mean if a slope is 0? Negative slopes go...
It has to do with the, wherever
Is it
the,
straight across?
yeah.
Straight across.
Straight across.
Go straight across, okay? In other words, it's actually called a horizontal line. Horizontal line has a slope equal to 0. That's because its x values can change and change and change however which way they want to, which is what this is showing you, even if you mess it up. The x values can change all over the place, but the y values match. The y values never changed. They stayed the same. So this line, actually, that we just found the slope for, here's the point. Let's call this the x-axis and this is the y-axis. This is our horizontal line. This is the point 1, 2, 3, 4, 5, negative 1, 2, 3. This is the point negative 1, 2, down 1, 2, 3. And notice that the y is always negative 3. That line that we just found the slope for is y equals negative 3, because it says, I really don't care what my partner is. I'll take any partner you want to give me, but I'm going to stay negative 3. That's just the way it is. Okay? Horizontal and vertical lines are kind of different creatures. Okay? They kind of violate the rules a little bit. Especially the ones about partners. Keep going, try another one. Again, evens, take the blue one first, then the red one. Odds, take the red and then the blue. Tell me what you get. Check with each other. Then tell me what you get. What'd you get? You got -7 over 0. We're going to find out. Anybody else get -7 over 0?
I did. You get 12.
Okay, what'd you get?
7 over 0. It's a vertical.
Okay. So some people got -7 over 0, some people got +7 over 0.
I
Right?
have a question. So if you say that this shortcut of taking the first one, the red one, then the second one always works. Which I like that better, so I hope it does, because the other way confuses me. I read left to right, not right to left.
Exactly.
But with that being said, if it isn't a question about like where this one is 7 over 0 or 0 over 7, like the last two problems have been, if they both had a denominator or a numerator of something other than 0, and you got a different negative number, like how if you were 1, you got a -7, if you were 2, you got a 7, +7.
What that means is whatever the denominator was, if you're talking about the 7s being the numerator, whatever the denominator was, it's going to have opposite signs.
But would that still
I mean,
work
if
in
you're
any
Yes,
problem?
it still works, as long as you keep your points together. First one comes first, second one comes second, because what I'm hearing is that's the way you like to do it. You want first one, then the second one, because you read from left to right, like I do,
Yeah.
like most of us do. Yes, that will always work, and you'll still come up. Notice here we got the same denominator, a different numerator, like before we got the same numerator, different denominator.
Yeah, I mean, the answer's still the same.
The answer actually comes out to be the same in both cases. Before it was 0, but what do we call this?
Undefined.
We call this undefined. And that's because you cannot divide by 0. That's one of the math commandments. Thou shalt not divide by 0. Okay? And it's right up there, number 1, at the very top. Thou shalt not divide by 0. Second one is thou shalt not take a square root of a negative number. You can't take square roots of negative numbers. Try it on your calculator and see what it tells you.
It'll say error.
It'll say error.
It doesn't say like syntax.
No, it'll say well, it might say syntax error. It might say error not real. Because electricians will tell you you can't take square roots of negative numbers, but that's because
Then you get imaginary.
you get imaginary numbers. And imaginary numbers aren't real. We're going to deal with real numbers, okay? So it's undefined. This slope is undefined. Now, if 0 is this way, and a positive slope, I'm trying to think with me, positive slope is this way, right? Negative slope is this way. What the heck does undefined look like?
Vertical line.
It's a vertical line. And that's because they don't slant. They're straight up and down. Okay? So if this is your x-axis and this is your y-axis, and you have a line with undefined slope, it might look like that. It might look like that. Both those lines have undefined slope. And this is different possibilities.
X equals -7, this is the line x equals 7, but they both have undefined slope. In fact, regardless of what that number is, any vertical line I want to draw on here has undefined slope. One of the things that we're going to talk about in this chapter is that vertical lines are not functions. They're not functions. And the reason that vertical lines are not functions is there is not a unique y partner that goes with that one single x partner. That x partner takes on multiple y partners. It's very polygamous. It is the ultimate in polygamy. It takes on all the different y partners. Okay? Now, this is my big caution for the day. You got a highlighter, I want you to highlight this in your notes. In your notes, I want you to write it. That's very important. The phrase "no slope" should not be used ever. Never, 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 never. Because some people, when they see the words, see the numeral 0, they think, oh, that means none. That must mean no slope. The slope is none, therefore it has no slope. No, it has a slope. Its slope is 0. 0 is a legal number. They get that mixed up with undefined slope. Okay, so we're not going to use the word no ever.
Does that specify when? Where? Specify where, when?
You specify whether the slope is 0, which is the line is horizontal, or undefined. Which means it's a vertical line. But don't tell me, well, this line had no slope. All lines have slope. Undefined slope. It's still a line, but its slope is undefined. It's undefined. Because it requires a process we're not allowed to do mathematically. Okay? This is just a quick rundown. We'll look at an overview of slopes. The y-axis, vertical line, undefined slope. Things that are the x-axis or parallel to the x-axis have a slope of 0. Horizontal lines all have a slope of 0. Everything else is a legal slope. These slopes are all positive. That means they go uphill from left to right. If the number is a smaller number, they don't go uphill as fast. As the number gets bigger, they go uphill very quickly. Okay? They're much steeper. So small slopes, less steep. Larger slopes, more steep. The same thing works with your negatives. These lines all slope downhill. Their slopes are all negative numbers. Okay? If you don't look at the sign, this is a smaller or a more shallow slope than this, which is a steeper slope. Okay? So still, as you go from fraction to whole numbers, or numbers more than 1, Despite the fact that they're all negative, look at the absolute value of that number. Don't pay attention to the negative, because the only thing the negative tells you is that it goes downhill. Okay? But the actual value of that number tells you quickly downhill or it's taking its time downhill. It tells you about the slantedness. Okay? Now we're going to talk about how do you find the equation of a line. An equation in two first-degree variables. First degree simply means that the understood exponent on both variables is a 1. Equation in two first-degree variables, such as this, has a line as its graph, so it's called a linear equation. This is called a standard form. This is not in your notes. The standard form is a number A times X plus a number B is equal to a number C, which is constant, and A, B, and C
are all real numbers. They can be positive, they can be negative. Okay? A and B can each be 0, but they cannot both be 0, because that means your variables will disappear. 0 times X and 0 times Y means no variables, they went away. Okay? Suppose a line has slope M and a y-intercept B, which should be written that way. I'll let the textbook's wording in there, but I'm correcting them. This means it passes through the point 0B, and if x, y is any other point on that line, then the slope, since this is a point 0B, x is 0, y is b. And if we have any other point, x, then y, then you can define the slope the way that it's defined there on that side. Let's carry that a little bit further. Let's simplify this by multiplying both sides by x. And keep in mind that this could just as easily be just that, because what's x minus nothing? 0. So it doesn't change x at all, took away 0 from it. So if that's actually the same as that, and when we multiply it by x, what happens to the x's?
Cancel.
They cancel. So that leaves us so that's the result of multiplying both sides by x. Now we're going to add b to both sides. That gets rid of it on that side. And we have y is equal to b plus mx. And if I switch that around, it's mx plus b. That gives us another version of the equation for a line. That's called the slope-intercept form of the line. That's the most common way to write the line, and it's also the way that you'll have to write the line in order to be able to plug it into your graphing calculator and graph. Okay? So that takes us here. This is the slope-intercept form of an equation. We will use that one a lot. It's also referred to as the function form of the line. The equation must be in that form to be graphed using your graphing calculator. Now, I'm going to stop there because it's 10 minutes till. I have a document camera, so I'm going to take the rest of these and finish recording this and post it all up online. And that's going to be before I leave today.
Your section 1.2 and section 1.3 notes are in Shelby. Okay, there's the link. It's the same link for 1.2 and 1.3. This covers both of them. That's the one you need to watch, finish filling in your notes. Okay? You can ignore that because this was a different way I was doing the lesson.
1.1 homework due at midnight.
Yes. If you have time to do 1.1 homework, there shouldn't, I don't think there's what, 6 or 8 problems? I may not count off if you turn in late.
There's 25.
Oh, we'll be extending that, yes. Go ahead, work on it, but you may not get
What
that.
are you talking about, on the lab or Shelby?
No, you're talking about,
I'm talking about math lab.
okay, no, I'll fix the date in my math lab. If I don't, please send me a reminder to fix it.
But the Shelby
Shelby
activity,
1.1 is pretty much due tonight, because you should be able to get done with it.
yeah, it's